Hello students, welcome back. Welcome back to our VTU channel. So, so today we are going to continue with our chapter 1, module 1. So couple of small chapters are remaining before we end up this. So today we are going to talk about storage class specifiers. Storage class specifiers. Okay. So there are 4 types of storage class specifiers. First one is auto. So first one is auto. Second one is register. Third one is static. And fourth one external. Okay. So what are these storage specifiers? So storage specifiers, you can say, basically will tell compiler to how to store in memory. How to store in memory. Okay, basically these will tell compilers how to store in memory. Okay. So first let's see about auto. Auto is nothing but your default one. Right? Say int x is equal to 10. So by default it will be stored in RAM. Okay. So the keyword is auto, but as it is by default, we normally ignore this. So if it is ignored, then it is by default auto. Okay. Now, what is register? So register, if I say register int x is equal to 10, this will be stored in registers. The registers of CPU. What is the use of storing in registers? Quick access. Correct? If you require any variable to be accessed very quickly, register is a way to go. Commonly, we don't store anything that's going to be changed. Commonly, we will store a constant here in register so that it is accessible very frequently. Correct? So, that time we can store it in the register. Okay. The third one is static. Okay. Static is something, it doesn't change the value. Value will not be changed. So yesterday we also learned const value will not be changed. Okay, what is the difference between static and const? So the major difference is okay. Let's consider a block. If let's consider if block. Okay. const x is equal to 10 is accessible within this block because it's within this function. Assuming within this function. Okay, in some main function. Okay, here if I give static int z is equal to 0 and print f, so what will be the value printed here? This int. So let's remove the static for now. If I do like this, it will give you an error for me, compiler, because this is not defined. Now if I do static, okay, now this value will be remembered and we can easily print out here. Okay, the const is declared and its value cannot be changed. Static is in any block. Okay, so now let's say I move this const here. What will happen now? Okay, this will throw out an error because x is not defined. Is a constant is defined here, but this is limited to this block, right? It's a block, correct? But this static is accessible outside the block also. Okay, so we can print it. So this will pass. This will error out. Understood? That's the main difference between constant and int. Now, external is short form of external. Why it is the use of its external? Correct? So, in real world application, there will be many files, right? File 1.c, file 2.c. Okay. Now, there is some variable int p is equal to some number 2. Okay. If I want to access this value in p, in here I will write external int p. So if I print it here, so I will be able to print it. Okay, so I will be able. This is, so this will let external keypad will let the compiler know this value is taken from some other file. So it will search in different file and get that value here. Okay, and the thing is, this will not allocate any memory. No memory is allocated. Okay, this one I have to by default RAM. This is for register. Static also RAM depending on the conditions. Okay, and here no memory is allocated. And how? Memory is already allocated when we do this, right? This memory is only going to be used. Okay, and this one, what is the static? It will be used outside the block. Value will be written outside the block. Okay, so these are the four class specifiers or to register static extra. Okay, okay. So next we are going to learn about variable initialization. By default, a variable is written as type, that is data type variable name is equal to a constant value. This is the default. Okay, so example int data type variable abc is equal to 10. Okay, this is how variables are. Now if I don't initialize this, I just say int abc, what will be stored here? If it's a local variable, the garbage value will be stored. But which garbage value? What is the garbage value here? Okay, garbage value is nothing but when I say initialize, it will allocate it in the memory. Whatever will be there here, right? What garbage value will be displayed, will be pointing to. Okay, in case of global and static, when you initialize, then 0 will be stored. Okay, this is about initialization, variable initialization, and you have done it in every class. I think we have done this variable initialization. Okay, next we are going to study about constants. As already shown, constants are the values which don't get changed in the program. Okay, there are many types of constants. Integer constants. This int is equal to 10. Const. So this value will not change. Char x is equal to a. We are giving it in under the quotes, right? It represents a constant. Okay, because this is value cannot be changed. Okay, this is a constant value. There can be hexadecimal 017, octal number, hexadecimal number. Okay, the different constant, floating point constant, pi. So these are all the examples for constants, and there are many constants. Okay. Okay. Now let's study about the operations. Operations in C. First is arithmetic operations. What are your arithmetic operations? Plus, minus, multiplication, division, modulo. Okay, as you also already seen in the examples, you can say int a is equal to 5, b is equal to 6, c is equal to a plus b. Similarly, you can say B minus C, A into B, A divided by B, A modular of B, A modular of A, anything. So these are arithmetic operations that you can do it in a program. Second is relational operator. Relational operator. Relational operations. Okay, what are relational operations? Less than or less than, greater than, less than or equal to, greater than or equal to. Okay, this is equal to. Okay, this is a comparison. If you use a single, this is a initialization, right? X is equal to 10. This is initialization. To compare the values, we are saying double equal to. If it is not equal to, then it is exclamatory marks with equal to. That is, say not of equal to, not equal to. Okay, these are operations. These operations will result in either true or false. So these are basically conditions. Okay. Apart from this relational operations, we also have logical operations. What are logical operations? The major ones are or, this or this. Okay, it's X or Y. If any one of it is true, then it is true, else false. Any one. Then it's true. If both are false, then it is false. Any one should be true to be true. Okay, so you might have heard in this one, 1, X is true, Y is false, then it is 1, true. This is 1, this is 0, X is 0, Y is 1, then it is also 1. X1, Y1, that's also 1. X0, Y0, then it is 0. So if both are false, then only it will be false, otherwise it will be true. Okay, so that is the OR operator, or logical operator. Next one is AND. It is the opposite of OR. Both has to true to say true. If any one is false, then it is false. Okay, true and true is equal to true. Similarly. Okay, and one more we have exclamatory marks, that is the inversion operation. So if I say true inversion, then it will be equal to false. Example, equal to, right? We remember this, right? Not equal to. Similarly, you can say A is not equal to B. This is a condition, then it is, that is making it as inverse. Okay, now we have some assignment operators. Very important assignment operator. You will see many times. So what we are using is, these are basics. These will be used in every programming. Anywhere, whenever you go to program, these are very important. Okay, these are simple mathematics stuff, but it is very important stuff. So now assignment int x is equal to 10. This is the assignment operator. Okay, there are many assignment operators. So next, let's say int y is equal to x plus 1. What will be the value of y? It will be 10. Okay, next what we can say is y is equal to plus plus x. This will be 11. Here both will be 11. X is equal to 11 and y is equal to 11. Here what it is happening is plus plus operator. What it will do is it will increment the value whichever is here. It is doing pre-increment, that is it is incrementing this from 10 to 11 before doing the assignment, hence it is taken it y as 11 otherwise. Now if it is a post one, let's say y is equal to x plus plus. Initially the y value will be assigned to this, then x will be incremented with 1, it is 11. So x plus plus will be previous value of x plus plus, as it is the post one, not the pre one. So initially the value will be applied to this and then the increment will happen. Okay. So now let's see an example. X, okay, y is equal to 3. Next if I say y plus equal to x, what will be the y value? This time the y will be retained first, then it will be added with this number. So that will be the value will be 13. Okay. So this is assignment operators. Now we have one more conditional operator. If A is equal to B, then then true, false. Okay. Now consider simple. Int A we have some value. Okay, from user we are taking value. Okay, we have A and int B. From user we are taking the value. We have to find out the max. So if I say max, if A is greater than B, question mark, A is greater or B is greater. So if I set 5 and 7, 5 is greater than 7, is it true? No. Then it is the value will be B. Then it will go to B, that is 7. So the max is 7 here. Okay. Similarly, if I say here, let's say 8, 3, then the value here will be 8 greater than 3, that is 8, 7, 8, 3, so the value will be 8. So this is a conditional operator. Okay, it evaluates the condition and depending on the response, it will print out the result. It is saying either this or that. Bitwise operators directly work on the bits, that is 1 bit, 2 bits, right? 1, 2, 0, right? Bitwise operators. These are AND, OR, XOR, sorry, this is XOR to be in the top corner, cap, okay? It is bitwise NOT, left shift, right shift, okay? So let's see bitwise operator 1, 1, okay? Now this is NOT, sorry, this is OR. As I explained before, right? If both are true, then only it is true. If any one is true, this is true. Now consider an example for this. For this, consider 5, 3. What will be the output? Now, this or this 5. How can you write 5? 5 you can write is a 0, 1, 0. Okay, this is 5. And 3, 0, 0, 1, 0. Sorry, 0, 0, 1, 1. This is OR now. Between this OR. So this or this 1, this or this 1, this or this 1, 0, 0. So what is this? 7. Value is 7. So now the bitwise operators are operating. Similarly, if I say 5 and 3, 0, 0, 0, 1, 1. Now there will be AND 1, 1, 0, 0, 0. It will be 1. Value will be 1 for AND. This is for OR. Coming to the bitwise XOR, right? XOR. If both are same, it will be 0. If any one of it is different, then it will be 1. Okay, so consider taking our example 1, 0, 1, 0, 1, 0, 0, 1, 1. So both of 0, 1, 1, that is 6. 5, 3 is 6. Now coming bitwise NOT, it will make negation. Bitwise NOT. Okay. Now the 5's value is 5 is 0, 1, 0. What it will make? It will make it as negative. How it will make this negative? We have to add 1. Correct? So we have to convert that to 1 to 0, 0 to 1, then add 1. This is 2's complement. So this is negation. Okay. Basically, if you are putting 8 bit, it will be 8 bit operator. 8 bit will become 1. Okay. And you can understand. Now the shift operators. Left shift, right shift. Let's say 5 left shift. What will happen is, initially the 5 value is 0, 1, 0, 1, right? The left shift, what it will happen? It will shift. And here 1, 0, 1, 0. 0 will move. From here, the last end, it is supposed to, it will come here. Okay, so that is left shift. Similarly, the right shift. This will go to the front for 8 bits. Okay, this is how it will shift. One position will be shifted, and the last one go to the front. Yet the last one goes to the back side. Okay, these are bitwise not operator. Thank you.